Hey everyone, we're the Earth Systems Explorers CS Flare team, also known as Citizen Science, Fire Likelihood, and Risk Evaluation.
So let's start by talking a little bit about why wildfires are such an important issue. While many of us often associate wildfires with rural and uninhabited areas, they actually cause high levels of damage to both urban and suburban areas as well. In fact, in 2023, over 3,000 homes were destroyed by wildfires and over 2 million acres of land were burned in the United States. We wanted to pursue a project that would allow the general public to be more involved in the wildfire risk management of their own homes and suburbs.
Applying the knowledge we learned throughout the course of the CEASE program, we asked ourselves, how can we utilize the Globe Observer database and satellite imagery to create a tool that provides users a greater understanding of wildfire risk on a community level? Our answer to that question is CS Flare.
Our goals for CS Flare are to inform citizens of fire likelihood and tips for wildfire prevention in their area, and to effectively use existing satellite data and machine learning models.
We wanted to enable citizens to take the initiative in protecting themselves and their communities. Through citizen science, we wanted to make satellite data available to everyone via a personalized fire risk evaluation. On top of that, users will be able to get advice from reputed resources on lowering that score. So we decided to make an app.
CS Flare begins when a user takes 5 pictures, 4 in the cardinal directions and 1 downwards. Once the pictures are taken, they're then identified using a machine learning model to identify potential fire hazards, like dried brush or grass dryness levels. Before calculating the final fire score, environmental indicators from satellite data are also considered. These factors are then combined to determine the final fire risk score. Finally, the app displays the score along with recommendations to improve it.
To plan out the creation of our app, we created a wireframe using Figma. After the user uploads their images, they will be able to explore the exact risk found in their pictures and be recommended advice to lower those risks. The development of the app has progressed in the Flutter framework, programmed in the Dart language, and we plan to use TensorFlow Lite to integrate the AI models.
We trained the Google Teachable Machine on downward images on the Globe Observer land cover dataset to classify vegetation dryness. As it's seen on the left, we were able to create a model that analyzes grass moisture on a high accuracy. We also created the fire risk factor assessment by fine-tuning the YOLO V8 image segmentation model on the north, east, south, and west images from the Globe Observer database. The output of the model, shown on the right, precisely segments vegetation in a variety of environments, proving effective in identifying high-risk wildfire threats.
CS Flare is able to accurately recognize significant fire risks surrounding the user's location, as well as a fire risk rating determined by satellite data regarding the user's area of interest. Using machine learning models trained by Globe Observer data, users can detect environmental factors at high accuracy and provide them with relevant information about how they could reduce fire risk around them.
CS Flare's strengths include its ability to leverage reliable data from the Globe Observer database and provide a comprehensive risk assessment by analyzing multiple environmental factors using advanced image segmentation models. Some weaknesses include its focus on a limited set of environmental factors and dependency on the quality and availability of citizen science data. In the future, we hope to collaborate with local government agencies to expand the app's capabilities.
Amongst our reflections, getting the opportunity to work with equally passionate students allowed us to develop our collaboration skills while also learning about different approaches to scientific research. Furthermore, lectures from reputed scientists such as Dr. Burdest, Dr. Yang, and Dr. Lind helped us gain essential insights. As a whole, the opportunity to create our own science identities and projects definitely made this experience unique and memorable.
And finally, a very big thank you to everyone who helped us with this project, our ESE mentors, peer mentors, the CSRC staff, and the partners of the NASA CEASE program. Thank you.